All right. So, okay. So, yeah, the set of vectors. Yeah. Or two-dimensional. It could be two-dimensional and three-dimensional or in n-dimensional. A set of vectors. Let's say V, capital V, uppercase V. This is a set of vectors of, let's say, two-dimensional vectors. It has this property. When you add any two elements in this set, so the order does not, it is not important. Order is not important. So you can add anywhere, anywhere you want, right? So this property is there, right? And associated property is there, right? All right. So let's talk about scalar multiplication, right? So when you multiply a vector, so let's consider this vector. All right, this is the magnitude and direction is in this direction, right? So when you multiply this vector by a positive scalar, so then what happened to the resultant one? So what happened to the resultant vector when you multiply this one by 2? What happened to the resultant one? So the direction does not change, but the magnitude would be double, right? So, when you multiply a vector by a scalar, direction does not change. Positive scalar, right? Let's say C is a positive scalar or real number, right? So when you multiply this vector by this positive scalar, so direction does not change, but its magnitude will be changed, right? If you multiply this vector by 2, the magnitude will double, right? Yeah. Similarly, if you multiply this vector by a negative scalar, right? Right. Let's say, yeah, negative scalar, your direction will change. That direction, so this direction will change to other way, other side. But the magnitude, let's say C times vector V, magnitude would be, yep, magnitude of C times magnitude of vector V. Is that all right? Yep. Any questions? Any doubts? Any questions?
No, sir. No, sir.
Yeah, these are, yeah, I think you know these things. Yeah, we know these things. Let's, yeah, all right, thanks. Okay. All right, let's talk about, yeah, let's talk about this property here. Again, you have commutative property, right? So this time you will, yeah, you consider two scalars, alpha, beta. That means these are real numbers, right? Right. So first I multiply these two, then I multiply that one with this vector, right? Yeah, alpha beta a, right? So we don't know the sign of this one. If this is positive and this vector, yeah, if this is positive, direction does not change. If this is negative, direction changes, right? Okay, so right now I consider these, yeah, this one here, beta, yeah, beta a. I multiply a vector with scalar beta, right? Someone is, so what is that? Ah, 0, yep. So here, when you multiply this vector by 0, right? So when scalar is equal to 0, when you multiply v by 0, right, you get a 0 vector. So 0, the magnitude of 0 vector is 0, but so direction is not defined. It could be any direction. So for 0 vector, it could be, you can define any direction. 0 vector. It has, yep, 0 vector. We cannot define a direction, but we can say, okay, it is defined for any direction, right? But the magnitude is 0, right? So this, when you multiply this v by scalar 0, you get 0 vector. Let's write that down. 0 v is equal to vector 0. So the magnitude of 0 is 0, but the direction is a puzzle. Yep, could be any direction. The direction is anywhere. Yep, for 0 vector, right? All right. Okay, so I was talking about this property here, right? So when, okay, so a is multiplied by this scalar, and then you get this one, then bracket, then I multiply, this is a vector, right? Beta a is a vector, right? So I multiply this vector by alpha. So then you get another vector, right? So this vector is same with this one, right? Okay, this vector is same with this one. Similarly, yeah, you can swap these two scalars. You can swap because the set of real numbers has a commutative property, right? Remember, right? Set of real numbers, alpha, beta are real numbers. So it has this set has commutative property, and multiplication or addition, and addition, right? Alpha times beta is same with beta times alpha, right? Because of that, yeah, alpha times beta is same with beta times alpha. I will give some problems on this. on this one, then you will understand these. So these are basic properties, right? So if you have two scalars, then you can, so here addition of two scalars times this vector, then you can expand this bracket. So this one is same with addition of this vector and this one, right? And similarly, yep, here you have a single scalar, and this is here you have addition of two vectors, then you can, yeah, you can span this bracket. So this one is with alpha times vector A plus beta times, no, alpha times B. So this property is called distributive property. Yeah, this property is so commutative property. Yeah. So because real numbers, the set of real numbers has a commutative property, so then this one also true, this one is true. All right, so these are the special properties, right? A set of vectors has, right? I will give some problems regarding this. Yeah, these properties, then you will understand how to show the commutative property, how to prove the associative property, right? All right. So I will give some exercise regarding these properties. All right. All right. Now we are going to talk about position vectors. Right. So for that to talk about position vectors, you need a reference frame, right? So I think you have learned two-dimensional vectors in your A levels, right? So we have two axes, x-axis, and y-axis, and this is the position, right? Yeah, P is the position, and this is the origin, right? Then you can define OP vector if you know unique vectors along these axes. Let's say, all right, this is the unique vector along OX axis, and this is the unique vector J is the unique vector along OY axis. Then you can define this OP vector pretty easy, right? So OP, the magnitude of OP is this length, right? This line segment, the length of this line segment. Then you here you know the angle, right? If you know the angle here, then you can find this length here, right? So this, let's say this length is px, right? This you know this magnitude here px, you know a unique vector along this axis, then you can find this vector here or px. Yeah. So let's say this length is px. Yeah, this is the point, right? this length is px is equal to OP cosine theta, right? OP cosine theta. All right, so this is a magnitude, and if you know the unit vector along this axis, then if you multiply this quantity with this a vector, unit vector, what do you get? So you get OPX vector, right? So OPX, this point PX, right? This point PX. So OPX vector is equal to OP, this length, OP times cosine of X, cosine theta times the unit vector along OX axis, I. Likewise, you can find OPY vector, which is equal to OP sine theta. What is the unit vector along OY axis? J. All right, so you know this vector as well as this vector, that means this vector, right? Both of what is the direction? Both directions are the same, and magnitude also the same, right? Both are the same, right? This is O P Y. OPY vector, which is equal to OP sine theta, and what is the unit vector? J. Yeah, J. Then you can find the vector OP. The vector OP would be OP cos theta, cosine of theta times this unit vector, right? Plus this vector OP sine theta times this unit vector. So likewise, you can define this vector here, and you can find this angle very easily, right? Right, if you don't know the angle, you can find that one, which is tan of theta is this length divided by this length, and then you know the angle. So these are A level. All right, so I think in your A levels you have learned these things, right? Two-dimensional vectors. This is called a position. So this is a position vector, right? OP is a position vector, and this is called the origin, right? So so you know how to find that one. And let's consider a three-dimensional vector. That means now you have three axes: x, ox, oy, perpendicular axis, oz, right? Have we learned 3D vectors in A level? So this time, no, three-dimensional vectors. So you know that in our world is 3D, three-dimensional. So we know that this is the width. So if you take an object, right? If you consider a cube, so it has three dimensions. So this is a cube, right? So this is the length, width, and height. It has three variables here. This is one variable, and second one is width, and third one is height. So it has, so we are living in a three-dimensional world, right? So this, let's say this is the origin, right? Okay, this is, so these are perpendicular, these axes are perpendicular to each other, right? So this, all right, this is OX, this is OY, and OZ, right? And let's take a point in this three-dimensional space, right? All right, P is any point in three-dimensional space, right? So earlier you had an infinite plane. This is a plane. So this is a point of a plane. Now we have a point in the three-dimensional space, right? All right. So now, okay. So now we have to find, yeah. So right. All right. So how do we find? So we know this length here, OP length. We know this magnitude. Okay. We can measure that. So the length, yeah, the distance between the origin and the point P, we can measure that. All right. Okay. Now, and yeah, so this one is the projection of this OP. Yeah, so this is the projection on OXY plane of this OP line segment, right? Oh, all right. So, all right, let's consider, yeah. So, yeah. So this is something like, yeah, shadow of this line segment. Shadow of this line segment on OXY plane, right? Okay. So, and this one is perpendicular to OXY plane, right? And how do we find these angles? You can measure these angles, right? Because you know this direction, then you can find the angle between OP and OZ axis. You can measure that, as well as you can measure this angle as well, right? This is the angle between OX and this projection. The projection of OP on OXY plane. So you know those angles, then you can find PX. PX means this distance. PY means this distance. And PZ means this distance. This is 90. Right? If you know these angles, and this is also theta, this one theta, and this is 90 degrees. Yep, you can find these lengths. Then if you know unit vectors along these three axes, this is I, this one is I. Yep, my pen is not working today, so you guys, this is the unit vector along OZ axis. Yeah, okay. And then you are able to define this OP vector. OP vector would be OP vector P. What is the magnitude of this? Yeah, I will put I will call px, right? This magnitude is px, right? And it's not working. Yeah, px, and let's say, yeah, this is the magnitude. Let's call px times the unit vector plus, and you can find py is this, yeah, py y times k. Unit vector is j, and the other one is, yeah, pz times k. Yeah. Yeah, likewise, you can define position vectors. These are position vectors uh, according to these reference frames. So this is a Cartesian plane, right? Two-dimensional, yep, Cartesian plane. Then you can define, then you can find the position vector. If you consider any point on the plane, you can define these position vectors very easy. Finding these angles and this distance and this distance. Here you need three distances, right? Px, Py, and Pz. Then you can find the position vector P. All right, I think, yeah. So these are vectors in 2 dimensions and vectors in 3 dimensions. Yeah, so we talked about, yeah, unique vectors. So we know that. So unique vector means its magnitude is 1, right? So unique vector is a vector with magnitude equal to 1, right? So for instance, yeah, if you consider this reference frame, OXYZ frame, right? So there are 3 unique vectors. I is a unique vector along OX axis, and J is a unique vector along OY axis, and K is a unique vector along OZ axis. The thing is the magnitude. If, yeah, magnitude of all unique vectors is equal to 1. Yep. J. This is, yep. Okay. And direction, the direction of I is yeah, in OX direction, like that, right? So unique vector in, yeah. So you know how to find unique vectors for given vector A. Yep. So let's say, so how do you find a unique vector of A? So A could be 2-dimensional or n-dimensional, right? So how do you find that? So the unique vector could be n-dimension, right? So this is the origin, and this is for case A, and this arrow represents the direction, and magnitude of this A is, yeah, this length, and let's say OA vector is this one, right? All right, so the unique vector along this vector can be found. How do you find the unique vector along this OA vector would be this vector divided by the magnitude of vector A. So this is the unit vector. If the magnitude is not equal to 0, let's assume magnitude is not equal to. That means it is not this origin, right? I mean, it has a magnitude. Yep. It has a length here. Yep. Yeah. So like that, yeah, likewise you can, yeah, you can find if you are given any vector, then you are able to find a unit vector along that direction. So I will give some exercise on these. These are A-level, yep, subject areas, right? So do you have any questions, any doubts, or yep. All right, let's look at this. Any questions before moving into any doubts?